Hello guys, welcome back to our discussion of first order ordinary differential equation. Previously we discussed how to solve first order linear differential equation, first order separable equations, and the equations which can be reduced to first order linear or first order separable equations using some substitution. Today we are going to talk about exact equations. So our topic of discussion today is first order exact equations. Oops, I need to change the color of my pen. So we are going to talk about exact equations. So at first it might seem to you that they are complicated, but actually they are not. So just be with me, have some patience, and you will see they are easy, they are simple, very simple. So if we have a function fxy equal to z, then the total derivative, if we take the total derivative of this function, is going to be dz equal to the partial derivative of f with x times dx plus partial derivative of f with respect to y dy, right? But if this function fxy is constant, we will get that the total derivative is equal to 0. The partial derivative with respect to x we are denoting with fx is equal to fx dx plus fy dy, right? So for example, let's take a very simple example. If we are given x square plus y square equal to constant, and we take the total derivative, it will reduce to the differential equation. So the partial derivative with respect to x dx plus partial derivative with respect to y dy equal to 0. So x square plus y square equal to constant can be written in form of this differential equation. This is a solution of this differential equation. These exact equations are very useful for the engineering students. And so if we have a form fxy equal to constant, we can go to the differential equation, we can take the total derivative. But the good news is sometimes we can also go back. If we are given a differential equation which is exact, we can find out the solution. So let's first define the exact equation. Let's write down the explicit definition. So we are going to define exact differential equations. And we will say a differential equation of the form mxy dx. M is a function of x and y, n is a function of x and y, equal to 0, is exact if we are able to find a function fxy such that fxy, if this fxy is coinciding with the differential of mxy dx plus nxy dy, or fxy equal to c is implicit solution of, say, this equation. We can give some name star. Then we will say this is exact equation. But this looks complicated. But then the second good news is it's very easy to check if an equation is exact or not. So, how to check exactness of an equation? So suppose you are given an equation m dx plus n dy equal to 0, and you are checking the exactness, then this equation is exact if and only if the derivative of m with respect to y is same as derivative of n with respect to x. This m is coefficient of dx and we are taking the derivative with respect to y. This n is coefficient of dy and we are taking the derivative with respect to x. And if these two partial derivatives coincide, we will be sure that the equation is exact. Okay. Once we know that the equation is exact, how will we solve this? Okay. So I am going to show you one example how we solve the exact equations, and then we will write the procedure. So every time we first write the procedure and then see the example. This time I will show you the example, the steps first, and then we will write the procedure. And we are going to start with very simple example. Say x power 5 plus y power 5 dy over dx equal to 0. This equation is also separable. You can separate the variables and then solve it, but for the time being, let's check if this equation is exact or not. So x squared, this equation can be rewritten as x squared dx plus y power 5 dy equal to 0. Our m here is x power 5, our n, which is coefficient of dy, is y power 5. The derivative of m with respect to y, m don't have any y term, so the derivative with respect to y is 0. The derivative of n with respect to x. Now when you are taking the derivative with respect to y, with respect to x, we treat y as constant and the derivative of constant is 0. It means this equation is exact, right? So the given equation is exact equation. So this is going to be your step 1 to check if the equation is exact or not. In the step 2, what you are going to do in step 2, if the equation is exact, it means you are sure that there is a function f. There is a function f which is going to be the solution of this equation, such that fx is equal to m and fy is equal to n. This was the definition of exact equation. If the equation is exact, we have a f such that fxy is a solution and fx is equal to m and fy is equal to n. Okay, fair enough. So we can start working with any of these equations. If integrating m with respect to x is easy, you can start with this equation. If integrating n with respect to y is easy, you can start with this equation. So in this example, I am starting with fx equal to m. From here, if you want to calculate f, you integrate both sides with respect to x, right? So we will, let's write in a different color so that we can clearly see the step. We integrate with respect to x. So in the left hand side, we were taking it was derivative with respect to x, so you get f back. On the right hand side, we will get integration of m dx. Our m in this case is x power 5 dx. So we will get x power 6 divided by 6. We need to add a constant of integration. We are taking the derivative with respect to x and we are dealing with functions of two variables. So y we are treating as a constant. So the constant of integration is gy. Okay, this is the important point to note. Always remember, we are adding the constant of integration as gy. Now we take the derivative, we differentiate with respect to y. The equation we get, we differentiate it with respect to y and we compare with fy equal to n. So if we differentiate the above equation with respect to y, we will get derivative of x power 6 divided by 6 is 0 plus derivative of y. And fy is equal to n. In our case, n is y power 5. So from this step, you will get the value of g prime y. You can integrate both sides with respect to y. To get the value of g. So gy is equal to y power 6 divided by 6 plus a constant of integration. This time our g is only function of y, so we are adding a constant. Okay, now we know the solution already. So fxy is equal to x power 6 divided by 6 plus gy, which is y power 6 divided by 6 plus constant of integration. So our solution of given differential equation we know is fxy equal to c. So x power 6 divided by 6 plus y power 6 divided by 6 plus c1 equal to constant of this constant c is our solution. You can substitute c minus c1 as a new constant. Let's call it c again. So this is our implicit solution. So we can always substitute this c minus c1 as new constant. So we generally, when we calculate gy, we don't put this constant, because it doesn't matter if you put the constant or not. It's again going to be a new constant. So x power 6 divided by 6 plus y power 6 divided by 6 equal to constant is your answer. Okay. Now let's write down all the steps to solve the differential equation, to solve the exact differential equation. So here is the procedure to solve the exact equation. Step 1 is we check, so we are working with m dx plus n dy equal to 0. In step 1 we will check exactness, that is my equal to nx. If the equation is not exact, we won't proceed with this procedure, because this procedure is for exact equations. Step 2. Step 2 is you will decide if integrating m with respect to x is easy or n with respect to y is easy. So if the equation is exact, we know there exists a function fxy such that fxy equal to c is a solution to our ODE, to our given ODE, and fx is equal to m and fy is equal to n. Now you can choose which part you want to start with. You can start with fx equal to m or fy equal to n. So this procedure we are going to write with fx equal to 1, fx equal to m. So you integrate both sides. So fxy will be equal to integration of m with respect to dx plus a constant of integration in terms of y. In step 3, you will differentiate say this is equation number 3. Differentiate number 3 with respect to y and compare with n. So from equation number 3 you will get fy, and we know fy is equal to n, and from this step you will get what is the value of g prime x. So from this step we will get g prime y. Once you have g prime y, you will integrate with respect to y so we integrate g prime y with respect to y to find gy. Substitute your gy back in 3 to get fxy. Just calculating fxy is not enough. We were looking for the solution. So step 6, don't just stop at step 5, step 6 is important. fxy equal to c is solution, possibly implicit solution to given ODE. So these are 6 important steps we are going to follow. You don't really need to remember these steps. Just practice some more problems and these steps will be clear to you. In short, if I combine all these steps, your fxy will be equal to, in step 2, you get its integration of m with respect to x plus gy, and gy you will get by comparing fy equal to n. So we are basically considering all the n terms, all the terms of n which don't have any x. So nxy, or you can say n, ignoring x terms. That will be your g prime y. So you will integrate that with respect to y, and you will get your fxy. By ignoring x terms, I mean if you have say a term 4xy, you won't just ignore 4, you will ignore the whole term 4xy. Suppose your n is y square plus 4xy, so you will only consider y square and not 4xy. Similarly, if you are first solving fy equal to n, your formula will be, you ignored the m terms, you ignored the y terms. From the m, plus integration of n with respect to y. So go ahead and verify that this is the second formula you will get when you are integrating with respect to you are integrating fy equal to n first. And we will stop here today and see you in the next class. Till then, practice more and more problems about exact equation to make this topic clear. Bye bye. See you.